In this video, we are going to perform a two-way analysis of variance or two-way ANOVA, which is a test that you should use if you want to determine the effect of two independent categorical variables, also known as factors, on one single numerical outcome. This test also helps us to determine whether there is an interaction effect between our two categorical variables on our outcome. Here is the dataset we are going to use, which comes from an experiment used to determine the antibacterial activity of a certain plant on a selected microorganism. We have the two independent categorical variables, or the factors, and then we have the outcome measured in terms of zones of inhibition in millimeters. Here is the variable codings for each of the independent categorical variables or factors. For the plant extract, part of the plant was dissolved in water or aqueous, another one in ethanol, and then methanol. Then we also have the different concentrations for the different extracts. We have the low, medium, and high. Since we have two factors against one numerical outcome, that's zone of inhibition, then a two-way ANOVA will be the most appropriate. To run the two-way ANOVA, simply go to Statistics, Linear Models and Related, select ANOVA MANOVA, and then choose Analysis of Variance and Covariance. In this dialog box, we are going to choose the dependent variable, which is zone of inhibition. Then under model, we are going to click on the three dots here. We have got two factor variables as main effects. So the first one is plant extract, which we shall add to the variable list here. We also have still a factor variable, which is a main effect, and that is concentration. We also add it to the variable list. Additionally, we want to assess whether there is interaction between our two factor variables. So we are going to specify here, instead of main effect, we want to look at the interaction for two-way. And then you will see that now we have got two boxes to specify the variables. I would prefer to start with plant extract and then bring in concentration, then add to variable list, then click OK. Then you will see that in our model we have the main effects, plant extract, concentration, and then the interaction with a hash sign in between them to indicate an interaction term between plant extract and concentration. Then here we shall click Submit. Here is our output. We can see the command that you can use without going through the menu. On top here we have the number of observations, 90. We have the R squared, which is 0.867, implying that about 86.7% of the variation in our zone of inhibition, the outcome, can be explained by the variables we've included in this model, which is good enough. In the table, we also have the overall estimates for the model, and we see that the p-value is less than 0.05, indicating that the variables we've included in this model have significantly improved the model. Next, we can look at the main effects, but before we interpret these main effects, we need to understand the three hypotheses that are tested under a two-way ANOVA. If I'm to simply put it, the first two hypotheses relate to the two categorical variables. So here we would simply say there is no plant extract effect on outcome, then there is no concentration effect on outcome. Then the third hypothesis is about the interaction between these two. So there is no interaction effect of the independent variables on our outcome. So for the first hypothesis relating to the plant extract, we can say that the p-value is less than 0.05, implying that there existed statistically significant differences in the mean zones of inhibition for the different types of plant extracts. For the second hypothesis about concentration, we can see that it is also statistically significant, implying that there were significant differences in the mean zones of inhibition, our outcome, at the different concentrations of the plant extract. Then lastly, we have the plant extract concentration interaction, which is not statistically significant. So this implies that the effect of plant extract on zone of inhibition, our outcome, does not depend on the concentration of the plant extract. But from this, we can say that yes, the test only tells us that there are significant differences in the outcome as far as the plant extract and concentration are concerned, but doesn't tell you which type of plant extract specifically is different from the other, or which concentration has higher means compared to the other. To determine which groups are different from each other, we have to carry out post hoc tests. And to do this, we shall go to statistics, then go down to post estimation. In this dialog box, we are interested in the tests, contrast, and comparison. So click on the plus button to reveal the different options. Here, we are going to select the pairwise comparisons. So in these pairwise comparisons, we are going to choose for plant extract we wanted to see, and then choose which multiple comparison test we are going to use. Here we are going to choose Bonferroni method, click submit. In this table, we are also interested in seeing the respective p-values for each pairwise comparison. Therefore, under reporting tab, we are going to check the box for specify additional tables, and we select show effect table with confidence intervals, and then click submit. So we can see that for ethanol versus aqueous, the p-value is statistically significant. Methanol versus aqueous, this is also significant, and methanol versus ethanol, they are statistically significant. You can also do the same for concentration. So when you come to main here and you select, instead of plant extract, you can select the concentration. I want to remove this and then click submit. You also get where the differences lie. For example, here we can see that between the medium and low concentration, there were no statistically significant differences. They were similar. The effect, their mean zone of inhibition were similar. But when you look at the high versus low, this was statistically significant, and then high versus medium, this was statistically significant. You can go ahead and look at the mean distributions that are being compared here. For example, if we want to see the mean distributions for the concentration, simply go to statistics, summaries, tables and tests, summaries, and then select means. And for this, we are going to get the means for zone of inhibition, but we group this over concentration. Submit this, and you should be able to see, as we are comparing medium and low, you can see that low was 12.4, and then medium is 12.7. So this is almost the same, and so we can't see a statistically significant difference there. But when you compare high and low, if this is 12 and this is 14, there is a difference of close to 2. That is the significant difference we are seeing here. And when you also compare high and medium, the high is 14, this is 12, so it is about a difference of 1.58, which is also statistically significant. Here is a template that you can now use to report the results of this analysis. Feel free to customize it to your institutional requirements. If you found this video helpful, consider liking, subscribing, and commenting the video so that you don't miss out any of our subsequent episodes. So next we are going to look at one-way analysis of covariance, or ANOVA, which is used to assess the relationship between one categorical variable and a numerical outcome while controlling for a third variable, numerical in nature. See you in the next episode.